Okay. I'm a friend of Amy Cook's. I was told she is here. Could I see her, please?
No, you can't see her. She's in a Zoom meeting.
Where is she now?
Listen, if you want to take a seat, it's going to be a while. Go ahead and sit down over there.
I'll do math. All right, good morning, class. I know if you're like me, the first thing you thought when Governor Holcomb said we're just going to be done with school for the rest of the year, you thought, but we haven't learned the Pythagorean theorem yet, and Mr. Metcalfe said that was the most important thing in all of geometry. Yep, that was my first thought. Well, you're in luck. We're going to knock it out today. It's going to be a little different than if I was in the regular classroom with you guys, but we're going to do it. So here we go. Pythagorean theorem. Dun, dun, dun. All right. Now, first off, the Pythagorean theorem only works in right triangles. So if it's not a right triangle, it won't work. So all these triangles today will be right triangles. Now, most people, and probably your parents even still remember this, the Pythagorean theorem says a squared plus b squared equals c squared. And that's correct, but I want you to think of it like this. Leg squared plus leg squared equals the hypotenuse squared. Because when you first were introduced to the Pythagorean theorem, probably in middle school, your teacher probably always had the hypotenuse as the missing piece. So you would always have a squared would be a number, b squared would be a number, and then it would equal c squared, some missing number. Well, you're in the big leagues now of high school geometry, so it's not always going to be the hypotenuse that's the missing piece. Sometimes it's going to be the leg. So we're always, no matter what piece is missing, it's always going to be leg squared plus leg squared equals the hypotenuse squared. And unless you've been asleep for the first 3 quarters, you should remember that in a right triangle, the legs are the 2 pieces of the triangle that make the right angle. So leg squared plus leg squared equals the hypotenuse squared. All right, here we go. And that says all this right here. So take a few seconds, copy that down. There you go. In this situation, of course, the A and the B are the 2 legs, and then C is your hypotenuse. How do you know the hypotenuse, Mr. Metcalfe? Well, like I said, the legs always make the right angle, and the hypotenuse is always opposite from the right angle. It's the side opposite from the right angle. All right, any questions there? Again, hit pause if you need more time to write it, but I'm gonna move on and jump right into this lesson. Here we go. Okay, here's our first problem. You've got a 6, an x, and an 8, and we've got the right angle, so this is a right triangle, so we can use the Pythagorean theorem. For starters, who can tell me which sides are the legs and which one's the hypotenuse? Barbara Gordon. Barbara, which ones are the legs? The 6 and the 8, yes. The 6 and the 8 make the right angle, so they're the legs. And this problem is kind of like one you would have had in middle school where you know both of the legs, it's the hypotenuse that's missing. So let's go ahead and process it. So again, leg squared plus leg squared equals hypotenuse squared. So we're gonna, oh, you have an answer, Barbara? You think the answer is 10? Okay, we'll write that down. Let's see. Barbara, let's say, thinks it's 10. All right, so here's how you would do it. Again, 6 and 8, like she said, are the legs, so we'll go 6 squared plus 8 squared equals the hypotenuse squared, which that's the missing piece, so that's the x. You can write a c there if you like, but we're solving for x. All right, so 6 squared, again, is not 12, it's 36. That means 6 times 6, not 6 times 2. And same thing with the 8. 8 squared is 64, and that equals x squared. 36 and 64, boom, that's a straight up 100, and that equals x squared. But we want x, not x squared. So as you know, the best way to get rid of a square is to root. That's absolutely right. Root it, and then to be equal, you have to root this side. We do that because roots cancel squares, so that leaves an x equals, and everybody in here knows the square root of 100 is 10. Good job, Barbara. Questions on that one? Boom. Okay, move on to this next one. I'm going to give everybody, now that you've seen how to do it, I'm going to give everybody a chance to do it. And I'm going to pretend like I'm giving you 19 seconds. But I'm going to go ahead and jump right in. Who thinks they've got this one? Anybody? Dick Grayson. Dick Grayson, what do you think for this one? You think it's 3? I'll write that down. Anybody disagree with 3? Mr. Grayson, he says it's 3. We'll see if he's right. Again, the legs. Ooh, this time it's one of the legs that's missing. See, here's your right angle. So in this case, your legs are the X and the 4. So again, don't put the missing piece on the end. The hypotenuse goes on the end, not the missing piece. It's the leg squared plus leg squared equals hypotenuse squared. So hopefully Mr. Grayson said X squared plus 4 squared equals the hypotenuse squared. Yep, that's the hypotenuse because it's across from the right angle, equals 5 squared. So x squared, we don't know what that is, so we write x squared. 4 squared is not 8, it's 16. 4 times 4 equals 5 squared, which is 25. Then Mr. Grayson subtracted 16 from both sides, and that cancels out. So now he's got x squared equals 25 minus 16, what's that, 9? And then to find out what x is, he has to get rid of the square, and the best way to get rid of a square is to root, and then to be equal, you have to root that side. Roots cancel squares, so x equals, and again, another easy one. We all know the square root of 9 is 3. Good job, good job. Any questions on that one? Now, these worked out nice and smooth. The answers always were a nice integer. That's because these are Pythagorean triples. Those are special. Those, they're not going to happen all the time. Matter of fact, next screen, it won't be a Pythagorean triple. That's when all 3 of the sides of the right triangle are whole numbers. So in this one, we had a 6, an 8, and a 10. This one, we had a 3, a 4, and a 5. That's not going to always happen, all right? When it does, it's a Pythagorean triple. All right, so pause if you need to, write this down, but we're moving on. Here we go. Okay, and here's your little warning. They want it in simplest radical form. What that means is these guys are probably not going to work out smooth. They might, but probably not. Okay, who's got this one? Let's see. Alfred Pennyworth. You think you got this one, Alfred? All right, first off, what do you think? What do you think? 4 radical 21. Okay, that definitely is a crazy one. So Alfred thinks it's 4 radical 21. He's pretty smart for his age. We'll see if he's correct. And again, this is another one where the leg is missing, all right? Hypotenuse, we know that would be your C if you're an a squared plus b squared equals c squared kind of person. That would be your C. A and B, you can switch those up, it doesn't matter. But I'm going to go ahead and do leg squared plus leg squared, so 8 squared plus x squared equals the hypotenuse squared, which is 20 squared. Okay. 8 squared, of course, that's 64. X squared, we don't know what that is. And 20 squared is 400. All right. So then I'm hoping Alfred, he subtracted off the 64 from both sides. And if he did, he should have x squared equals, what's that going to be, 336. Now, you all, of course, check behind me because I'm freestyling this. So you all always check behind me. Don't just take my word for it because I'm the guy up here in front. Check behind me. Now, all we got to do is get rid of that square because, of course, we want to know what x is, not x squared. So this is going to be a crazy one. So to get rid of a square, we root and we root because roots cancel squares. So x equals the square root of 336. Not a perfect square. You could look at on our chart we made those last lessons when we did simplifying radicals. 336 was not a perfect square, so we're going to have to break it down. It's not going to be an easy one. Now remember, I do it Terminator style. I break it down by 2s, then 3s, then 5s, 7s, so on. So I'm going to break this guy down by 2s. So 336 will be 2 times $1.68, I think. And then that would be 2 times 84, 84, 88, 88, 84. And then that would be 2 times 42. And again, I'm doing this off the top of my head, so make sure you're checking behind me. 42 would be 2 times 21. Now 21 will not break down by 2's anymore, so I move on to 3. And that's 3 times 7. And 7's also a prime number, so we're done. Now remember, Miss Metcalfe says we always need to circle our terminal factors, or the prime factors. So we got a couple of, we got a bunch of 2's. We got 4 2's, a 3, and a 7. Okay, 4 2's, a 3, and a 7. Man, let me get some workspace here now. Yeah, let's put all this back into place. So my square root of 336 is really the square root of 2 times 2 times 2 times 2 times 3 times 7. So 4 2's, 1, 2, 3, 4, and a 3 and a 7. Blah blam. Okay, now remember from a couple weeks back, these guys are all in square root prison and they desperately want to escape. So they're discussing things out in the courtyard after lunch, and these two says, hey, we're going to try to make a break for it. And these 2 2's say they're going to make a break for it. The 3 and the 7, nobody they trust, so they're going to just stay behind. So when the warden turns off the lights, these guys make a break for it, and boop, 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 boop. One of those 2's escapes, his buddy dies, boop, boop, boop. Another 2 escapes, and his buddy dies, and then we're left behind, we're a 3 and a 7. So I'll show this baby step right there. All right, so once the dust settles, 2 2's escape. Now they multiply back together. So that would be 4, which is what Alfred said, 4 on the outside. And then on the inside, 3 times 7, that's 21. So Alfred is absolutely right. 4 radical 20s, 21. 4 radical 21. Any questions? Any questions? All right, this is pretty easy stuff, right? Okay, we got 2 more. I believe this is it, man. This is it. So who wants this next one? Who's got this next one? Let me see, I'm probably standing in the way. We got a 6, an X, and a 12. Anybody want to try this one? I know it's a lot of work, so I'll give you a few seconds. Give everybody a few seconds. Okay, who's got it? Let's see. Who haven't called on yet? Harleen Quinn. Harleen, what do you think? What do you think for this one? You've got what? 6 radical 3? Okay. Sounds a little weird, but I'll write it. 6 radical 3. Put that right here. 6 radical 3. Harleen. See if I spell that right. Okay, cool. All right. So again, this is another missing leg problem. All right, we got 6 for a leg. We got a missing leg X, and then of course the hypotenuse is 12. So we're going to say 6 squared plus X squared equals 12 squared. All right, any questions on that? Hopefully that's what Harleen did. 6 squared is not 12, it's 36. X squared is X squared, and 12 squared is not 24, it's a $1.44. And then we got to solve for X, so we got to get rid of this 36, so we'll go minus 36 and minus 36 over here. To be equal, you always want to be equal in equations. All right, so that cancels him out. So now we have X squared equals, what's that, about a $1.08? $1.08. So now that's what X squared is. But as Harleen knows, we don't want X squared, we want X. So to get rid of that square, she rooted and rooted, because roots cancel squares. And 108, again, not a perfect square. So we got to do some scrap work. Let's clear off some space here. And I need a bigger smart board, or a Promethean board would be nice. Clear off some area here. I bet Drew Brees is homeschooling his kids on a Promethean board. He's not messing around with this smart board stuff, especially a broken one. All right, so we're going to break down 108. 108, and as you know, Terminator style, I'm going to break it down into 2 times 54. Then 54 breaks down into 2 times 27. 27 won't break down by 2's anymore, so I move on to 3. That's going to be 3 times 9, and 9, of course, breaks down into 3 times 3. That's a 3, by the way, for you at home. And let's circle our prime factors. We got a couple of 2s. We got a couple of 3s. Actually, 3 3s. Wow, you don't see that every day. 2 2s, 3 3s. Okay, so the square root of 108 is really square root of 2 times 2 times 3 times 3 times 3. All right, so now everybody tries to partner up. A couple of 2s, a couple of 3s. 1 3 is going to get left behind. Boop, 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 boop. A 2 gets out, his buddy dies. Boop, 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 boop. A 3 gets out, his buddy dies, and you have a 3 left behind. So when the dust settles, the 2 and the 3 multiply into a 6. 3 stays by itself, and Harleen is absolutely right. Good job, Harleen. All right, last problem for today. We got 12, an X, and a 10. Anybody think they know the answer to this one? We'll pretend like we're pausing for 31 seconds. Okay, Bruce Wayne, we haven't heard from you today. What do you think it is? You think it's 2 radical 11. Okay, so Bruce is going with 2 radical 11, or 2 times the square root of 11. Let's see if he's right. Okay, in this one, we've got our leg. Ooh, we're missing a leg, so this is another missing leg problem. So you would say 10 squared plus x squared equals the hypotenuse squared, which is 12. So we're going to say 10 squared plus x squared equals 12 squared. Okay, 10 squared we all know is 100. X squared we don't know, it's just x squared at this point. And 12 squared is $1.44. And then I'm assuming that Bruce subtracted 100 from both sides, and that would eliminate that, and you'd have x squared equals 44. But we don't want x squared, we want x. So to get rid of a square, you root and root. Roots cancel squares, and the square root of 44, again, not a perfect square, so we'll do some scrap work over here, Terminator style. 44 would be 2 times 22, 22 would be 2 times 11, and 11 is a prime factor, so that's as far as you can go. So the square root of 44 is really the square root of 2 times 2 times 11. So 2 times 2 times 11. Now, they're going to try to partner up, see if anybody can escape. All we have is a pair of 2s. So lights go out. They make a break for it. Boop, 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 boop. One of the 2s escapes. His buddy dies, and the 11 is left behind. So you get 2 times the square root of 11. Nothing left to simplify. Bruce is absolutely right. Good job, Mr. Wayne. Any questions? Zip me a quick email between 9 and 12, and hey, even after 12, I'll probably check it out too. All right, tomorrow we'll have part 2 of the lesson, the converse of the Pythagorean theorem. So until then, stay safe, and we'll see you soon.